Okay, ladies and gentlemen, welcome back to Chapter 1. Today we're going to be starting 1.4, and again, just a recap of kind of where we're at. We have definitely hit this standard hard with our linear equations, and today with 1.4, we're actually going to start looking at our absolute value equations. We did this standard explaining our steps at the beginning of the chapter, and then this standard I haven't really addressed, but you've kind of been doing it all along. When we do our application problems, and I remember on the last section we did distance equals rate times time, you actually wrote that equation that you used to solve for the distance. So this a dot CED dot 1 has kind of been floating along the whole time in the back of your mind, and these two go really well together because after you write a linear equation, you then have to use it to solve. So you've really been doing it all along. The only thing that we haven't hit so far is our a.ced.4, and that's going to come in 1.5, which will be after this one, which is the last section of our chapter. So that's kind of where we're at. Now, 1.4, solving absolute value functions. First of all, let's define an absolute value function, or I'm sorry, an absolute value equation, which is an equation that contains an absolute value expression. Now, if you forgot absolute value, that's okay, we're going to review it. We've got our properties over here. And first of all, number one, the absolute value of A. Okay, so we're looking at those vertical bars is greater than or equal to 0, meaning is always positive. So if you forgot, absolute value is talking about distance from 0. So if you are on a number line and we have 0 and then 1, 2, 3, 4, 1, 2, 3, 4, -1, -2, -3, -4, and I ask you what is the absolute value or distance that -3 is from 0? We would denote that as the absolute value of -3. So the distance that -3 is from 0 is 1, 2, 3. Well, distance really can't be negative. You don't walk a negative distance. You just walk 3 paces or 3 steps. So the absolute value of -3 is 3. We could do it the other direction. 1, 2, 3. Absolute value of 3 is just asking you, well, how far is 3 from 0? 1, 2, 3. It's still 3 paces or 3 steps. So absolute value is always going to appear positive or always be positive because we're talking about a distance. Okay, now number 2, because of that, if you have an absolute value of a negative, it's really just the absolute value of the positive version. If you have A times B, so if you're multiplying two things together, you can just separate them and multiply them separately. And then same thing with division. If you have an absolute value of A over B, you can just write it as the absolute value of A over the absolute value of B. Those are some of our properties. They might come up. Now, for our purposes, this is really where we're going to focus, which is solving them. And this is a whole bunch of gibberish. Okay, I understand that, but we're going to do 3 examples that will hopefully make this more clear. So if we're going to solve this equation, the absolute value of something equals something, and then keep in mind this C value has to be positive. That's what this is saying. And you better be writing this in your notes. Okay, when C is greater than or equal to 0, meaning it either has to be 0 or positive, you're just going to solve 2 separate equations. One of them, you're going to knock off the absolute value bars and solve the equation, ax plus b equals c, or you're going to solve ax plus b equals negative c. And the reason we do both the positive and the negative is kind of this reason up here where we had this number line. Because if I'm at 0 and I go to -3, well, that's still 3 away. Or if I go to +3, well, that's still 3 away. So absolute value can kind of exist on both sides of the positive and negative and still have the same answer because we're just looking at the distance from 0, which could be either to the left or the right. Now, what about when C is negative? So that says less than 0. Well, if the C value here is negative, then this has no solution. And the reason it has no solution, and we're not even going to worry about it, is because how do you take the absolute value of something and get a negative answer? We just said distance can't be negative, so it's not true. It's not a true statement. It can't happen. Okay, let's take a look at some a little more simple examples. Number 1, solve the equation and graph the solutions if possible. So first of all, the absolute value of x equals 10. So they're saying, what value is 10 away from 0? Well, we're going to solve two related equations. The first one is, well, x equals 10. The second one, because we're just dropping the absolute value bars, would be x equals negative 10. And again, you drop the absolute value bars and then you do a positive version and then a negative version. So what number is 10 away from 0? Well, that's either 10 or negative 10. They're both 10 away from 0. So if we're going to graph that solution, we would have, let's see, negative 4, negative 8, negative 9, negative 10. We would have one of our solutions on negative 10. 8, 9, 10. We'd have another solution on positive 10. And then that would just be our graph, just two dots, 10 and negative 10. Letter C, the absolute value of x minus 1 equals 4. So what value can we put in for x that when we subtract 1 and then consider the positive version, we have to get 4? So the absolute value of something, subtract 1, I'm thinking like 5, right? 5 minus 1 is 4. Absolute value of 4 is 4. But what about negative? My distance has to be 4, but it could be positive or negative. Okay, so first equation, x minus 1, drop the absolute value bars, equals 4. Second equation, x minus 1, drop the absolute value bars, but then make your C value over here negative 4. Now, when we do this, you only change the right side of the equation, okay? This goes positive, this goes negative. You never change the left side of the equation. Don't do it. Okay, now we're going to solve. So I'm going to add 1, x equals 5. Well, let's see. 5 minus 1 is 4. Absolute value of 4 is 4. Checks out. Add 1, add 1. X equals negative 4 plus 1, negative 3. Well, let's try that one. Negative 3 minus 1 is negative 4. Well, what's the absolute value of negative 4? It's still 4. Okay, so x equals 5, first solution. X equals negative 3, second solution. And we're good to go. Letter B, the absolute value of 3 plus x equals negative 3. Now, I know most of you at this point in time would be very inclined to write 3 plus x equals negative 3, drop the absolute value, and 3 plus x equals positive 3. This would get us into a lot of trouble. Does anybody know why this is going to get us into a lot of trouble? And it's right here. And we tend to miss it because we're going fast and we're not thinking. How do you take the absolute value of something and get a negative number? You can't. Like it's not going to work. Which means this one, let's not even try. No solution. Which means we're not going to graph anything. We're not going to solve anything. We're just going to say this can't happen.